Excellent. Welcome, everyone. We have a great program in store for you today. We're happy to have you all with us. If you have not already become a member of PRSA, I do welcome you to join us, especially because we have great opportunities for networking, professional development, and honestly, camaraderie in the field. So I welcome you to definitely join us for that. In addition, we do have some volunteer opportunities in our different programs on the board. You do not have to be a member to be a volunteer, and we will welcome you. So if you have any desire to work on programs with me or in finance or other areas, please do reach out to us. Okay. Let me introduce our distinguished guest today. We have Dr. Shaw, who is a professor of information and computer science at the University of Washington in Seattle. He is the founding director and InfoSeeking Lab and founding co-director for Center for Responsibility in AI Systems and Experiences, RAISE. His research focuses on building, auditing, and correcting intelligent information across systems. In addition to creating AI-driven information access systems that provide more personalized, reactive, and proactive recommendations, he is also focusing on making such systems transparent, fair, and free of biases. So with that, I will hand it off to Dr. Shaw and let you know to hold your questions till the end. We will have some time for our Q&A. Take it away.
Wonderful. Thank you so much for introducing me, for bringing me here. Hi, everyone. I'm happy to talk about things that are very near and dear to me. I'm here at University of Washington. I do a number of things, but the primary thing that I'm involved in is the Center on Responsible AI. I started with AI long ago, way before it was cool. This is me as a student working with this robot called Asimo, which was Honda's robot. This was many years ago. This thing, which is supposed to be humanoid and looks more like an astronaut. It didn't really do much, but we worked with it in terms of its movement and as well as its natural language abilities. Things have come a long way since then. So obviously, we're going to talk about some of those things, what those new things are, and what do they mean for us. While I've been working in AI for a long time, since I was undergraduate student, it's really in the recent years that I've kind of rethought about a lot of AI things. So one place where I've gotten back into it with a very different angle is responsible AI. Some years ago, I saw this story, which is now actually pretty, received a lot of attention, at least back in the days, I think this was around 2016 or so, is this idea that AI systems making judgments, and this is a real system that was being used in criminal justice system called Compass, which was shown to have biases against certain kind of people, specifically people of color. And this was being used for making real decisions. This wasn't just some lab project. This was out in the field, and it had issues that were really being manifested in real life. It was impacting real people in a very meaningful way. Another thing that was an inspiration for me was this book by Safiya Noble on algorithms of oppression, right? So as you can see, even in this book cover, as you start typing in Google and it does auto-completion, it has these associations, these prejudice that you can say, well, it's just manifestation from our own prejudice. But the fact is, these are being amplified by the system, and that it just perpetuates some of those biases. So a lot of these things, started popping up, and that kind of made me start looking at this other side of AI as well. So all this time I've been looking at this rosy version of AI, very optimistic. And now there's also this other side. Now, I continue working on both sides of this coin. And so I consider myself an AI pragmatist, which means I'm not shutting things down because they got all this bias and other issues, or they are too unpredictable, or they have other issues. And I'm also not buying into the hype. It's like, oh, this is going to solve everything. Let's do everything with AI. So the question really for me, and I encourage others to ask, is how do you use this responsibly? Right. So today I'm going to start with some AI basics. And this is often I find this very important to just cover because often people kind of sort of know what we're talking about AI when we say AI, but often they don't. So I'll cover some of this definitions. It may seem like a little tutorial lecture-ish, but hopefully it will help all of us to be on the same page to have meaningful discussion about what are some of the opportunities and problems we find in AI. How are these being dealt with? So I'll talk about some of the efforts, including some things that are happening in my lab and elsewhere in the field, primarily as a way to show that it's not a very simple problem. These things that we are encountering are actually challenging. And then finally, I'll talk about if you're using AI in your own practice, what are some of the best practices? And of course, this varies from domain to domain, applications to applications, but some of the quick ways I can at least give you a sense of how to do this a little bit responsibly in your work. All right, so let's start with some basics of AI. AI, of course, is not a new thing. It's been around for decades. And decades ago, when the field kind of got launched, the primary motivation there was to create machines that mimic humans in different ways, their behaviors, their language, their actions, emotions, and so on. But how can you tell if you really created a machine like that? So the father of AI, Alan Turing, provided us this kind of a test where he said, put this machine behind the scenes, and if a human is interacting with that machine, and if the human cannot tell if that thing behind the scene is a machine or not, then the machine passes the test, what came to be known as Turing test, right? So for an artificial entity to show that it has the intelligence, it needs to pass this test where the human cannot differentiate between that and a real human. But there are limitations to tests like this. So even long before the current wave of AI that we've seen, people have been talking about how this is not really a good test. Why? Well, what if you have a system that is really good at pretending, right? And so it doesn't have a real intelligence, but it's really good at pretending. It could pass this test, but it doesn't really have that intelligence. And so we've already started seeing things like that kind of make us question, is this really a good way to judge if something has intelligence? So an example is something that American philosopher John Searle gave us, what he called a Chinese room. So here's a room where, and this is a thought experiment, right? Not even a simulation, a thought experiment. Imagine there is this room, inside that room, there's a man who has all the instruments like books, dictionaries, instruction manuals to translate Chinese to English and English to Chinese, right? Now, people outside of the room can send a message in Chinese, and what happens inside the room is this person is able to take that Chinese message, turn it into English through all these rule books things, and then respond in English, which then he turns into Chinese by following the dictionary and the rule books and so on. And so I'm sure you probably can't read this, what this person outside is saying, but he's saying whoever or whatever is in that room is an intelligent Chinese speaker. All right, so basically they have this perception that the person inside the room is intelligent Chinese speaker. And then Searle asked us, is that really good enough? And so he said, well, there's a difference between somebody pretending to be intelligent Chinese speaker and somebody actually being an intelligent Chinese speaker. what do you call the difference between strong AI and weak AI? So weak AI is where what's happening here in this room, where this person is able to give us the kind of a perception of it having that intelligence, but it doesn't really have that, right? All that person is doing is simply following blindly, some rules and being able to do that in real time. But he doesn't really speak Chinese. He doesn't really have understanding of Chinese versus somebody who would really understand Chinese and can really converse without the help of these kind of tools. So that would be a strong AI. And again, the reason I bring up this differences is because often when we are having these conversations about what's AI and is it good or not, we miss this idea that, look, there are a lot of AI systems that are not really intelligent, but that's okay. They get the job done. So in this case, this person is able to converse in Chinese. So what? He doesn't understand Chinese. Maybe that's okay with you, right? And so maybe we don't need to worry about or insist on that person having real intelligence. So again, often when we talk about AI, what is this a strong AI, weak AI? Which one are we looking at? And what we see today, a lot of these systems are really examples of weak AI. They don't really understand, they don't really have that intelligence, but they are so good at pretending that for us to understand the difference. So narrow intelligence, general intelligence, and super intelligence. Artificial narrow intelligence actually has been around for several decades now. So this is where AI is developed to do a specific kind of task, and it achieves excellence in that so much that it can even human. So here's one example. IBM's Deep Blue defeated the chess grandmaster at the time. I believe this was 96, 97. Right? So here's the AI that's mastered chess, can beat the chess players, the best chess players in the world. Years later, IBM had another ANI called Watson that defeated the Jeopardy champs, right? So now you have this AI that's really good at that particular task. So but it cannot go across the task. So the one that was that won at Jeopardy cannot play chess. The one that played chess cannot drive your car, right? So it's really designed for that narrow domain, that specific application. So these are cases of artificial narrow intelligence. Artificial general intelligence, on the other hand, is really what we are. So not artificial, but general intelligence is what we have, humans. So humans are generally intelligent. We're not just designed for one specific kind of task. We do all kinds of tasks, and we have something that cuts across all of them, right? So we have a form of intelligence that is independent of a task. And because of that, we are able to self-learn, self-regulate. We're able to map the push now is that, oh, we have AGI, or we almost have AGI. So for instance, this paper from Microsoft that came out last summer, and it talked about, as you can see, they talk about sparks of AGI. So they are saying here that, hey, our conversations with GPT-4, which was the newly released thing at that time, is starting to show as if the system really has general intelligence like humans do, that it's able to connect these dots, work across multiple domains, evolve with its understanding, and even starting to feel, right? So many people, including myself, will push back on this, that that's not it, right? Maybe you can get away by calling it sparks of AGI, but we're not there yet. That being said, we are definitely getting closer, and I do believe, and by many estimates, that we will see AGI in the next few years, in less than 10 years. And that's going to have tremendous implications on everything around us. So right now we're creating this big, kind of this wave of AI, but AGI will really push us in the next level. ASI is even further. So this is where a general intelligence system gets even smarter, even better than humans. So AGI essentially is trying to really go back to that original idea of AI, mimicking human behaviors, being like humans in cognitive intelligent tasks and so on. Super intelligence is essentially just developing a whole new species that is superior than us. Now, of course, you can question, why would we want that? Good question, and we can have all kinds of philosophical discussions around it all day. But the point is, this is the next level. To the best of my knowledge, connect the dots, can have general intelligence. You don't have to explicitly work on ASI. It could actually happen. And so a great and a scary example of ASI is, of course, Terminators, right? So this is, of course, sci-fi version of it, where machines gain this kind of super intelligence where they are able to, work at a higher level than just humans. They have this intelligence. They're able to connect. And of course, in this case, they end up deciding to remove humans from the equation. So again, I wouldn't worry about this right now. This is not something that often people want to talk about this, but this is not on our horizon. That being said, there are some of the things that are already happening do raise a question at what point we really lose control and something like this starting to happen, right? And so I think it all comes down to how we are approaching AGI right now, rather than whether we should do ASI or not. Okay, so these are some basics of AI in terms of how we talk about AI. Next, I want to touch upon a couple of concepts that we often hear about and maybe perhaps not appreciate as well. One of them is language model. So you hear a lot of large language models. If you use ChatGPT, other things, those are forms of those. So what is a language model? It's nothing but it's essentially a statistical model that captures the probability distribution over strings of text. So what do I mean by that? So imagine if I give you a string like this, a quick brown dog, and I ask you, so imagine you know English and Spanish and French, and I ask you which language is likely to have generated this string. And you're able to answer that and say, oh, this is in English, or this message is in Spanish, or whatever. You're able to do that because you have a model of those languages, and you're able to answer which of them is more likely to have created this. And if you are able to do that, you could also generate your own text in that. So you can answer this question, and you're able to answer that because you have the model of that language. You know how that language works in terms of what it contains, what are the ways strings get generated, why one string is more likely to be from that language than the other string. And that ability also gives you a way to generate new text. So I can then give you part of this string, right? I can say a quick brown blank, and then you can fill it up with maybe dog, maybe squirrel, maybe something else. But you're able to do that because you have that understanding or language model for that language. So large language models essentially just take this up a notch. And what they're doing is doing what the humans do, which is, the way you've learned this, you've developed this model is because you have experienced so much stuff. Let's say you have English language model. You've witnessed so much stuff in English. You've read a lot of stuff. You've heard a lot of stuff. You've spoken a lot of stuff. And because of that, you're able to capture these associations. So large language models kind of do a similar thing where, again, if I give you the cat is chasing the blank, you're able to finish that because you've seen so much of this stuff. The cat is chasing something, right? Maybe, it's a dog, it's a squirrel, it's a mouse. But these are the things that you can come up with. So there's no one definitive answer, but you may have learned these kind of things implicitly. So large language models are essentially doing something like this, where through tons and tons of these messages, they have trained, they build this model, just like we would do, that allows them to fill in the gaps, that allows them to predict the next token or the word, next sentence, next paragraph, and so on. So when when you're interacting with things like ChatGPT or Copilot, you're basically seeing that in action, where it's able to go next token, and so on, and completing sentences and paragraphs and more. So it's reasonable to ask if LLMs are basically, they can do everything, anything, and certainly there are people who are using it for all kinds of things. Are they really limitless? And so I often use this movie reference, which is called Limitless, and it's a sci-fi movie where they say, well, most humans, we use part of our brain, some percentage, but you take this magic pill and it allows you to use your full, brain. Now, that doesn't mean that somehow you get new knowledge, but by taking this pill, it's able to connect the things that you've already seen, right, in your life. But normal human beings, we kind of forget things and we lose the connection between things. So this pill essentially just allows you to make those connections that's been forgotten. Because of that, it gives you this superhuman intelligence. So LLMs kind of work like that. They're able to connect existing things. So they're not able to predict the future. They're not able to really do anything that's outside of their training data. So they greatly depend on how they're trained and what was given to them, just like humans, right? But humans do have imagination, so we are able to go beyond just what we've been able to see. Things like ChatGPT, of course, they do some other enhancements on top of that. They have fine-tuning, they have guardrails, and a lot of things. But at the fundamental level, LLMs are limited by the training that is given to them. These things, and when you hear this GPT, all of these models are sort of GPT, and it stands for generative pre-trained transformers. So these are generative model, that's what generative part. Pre-trained, and this is important, that this is like typically in machine learning and AI, you would design system for a specific application. You want to do classification, you'll build a classifier for that. You want to do clustering, you do that, for that. But these models, they're sort of generic, general purpose models that they've been given all this training data, and they're built and they're kept there for any kind of application down the stream, right? So they're pre-trained and they're without any specific application in mind, but they seem to encapsulate some knowledge that we can now use for question answering, summarization, synthesis, text generation, all kinds of things. And transformers is a technical block that drives these things. So there are forms of neural network that allows these systems to make those word associations and help them generate the text. So GPTs are form that are used very much in text generation. When it comes to image generation, one of the foundational blocks often is what's called GAN, or generative adversarial network. And it has two components. There's a generative component and there's an adversarial component. The reason I talk about this is it's important to understand how these are designed. So the generative component, imagine you're playing that game, 3 truth and one lie, right? Or something like that. So I'm giving you 4 things. One of them is a lie. Can you detect which one is a lie? So that's what the generative component does. It produces some lie, and the adversarial component is supposed to detect that lie. If the adversarial component can detect it, then the generative component goes back and is like, okay, well, I gotta make up a better lie. So it does that, goes back, and keeps doing that until it starts fooling adversarial component most of the time. So the reason I'm mentioning this is for you to appreciate that when we often talk about, can we detect, something is fake or generated? You see the challenge that the generative component is specifically designed to fool any adversarial component that could detect. So generative component doesn't really understand things. It doesn't really, know things. All it's doing is generating things that will fool anyone trying to detect it. So, so that's some of the basics. Let's now talk about how these things are being used, and where they should not be used. There are some of the problems. So I'm sure you're already familiar with some of these models, some of these tools for text generation. Things on the right side are multimedia generation. They generate images, videos, so they're becoming more and more accessible, prominent. There are lots of opportunities with this. People are using it for writing messages, creating dating profiles, resumes, proposals. There have been cases where these things are, they have actually pretty much replaced the customer service department. In many cases, in many other cases, they have augmented it. So they're helping with those things. There are uses in education, art, content generation, healthcare, pharmaceuticals. They're being used to create new, or test new drug compounds. So there are lots of great uses of that. Here's one use in accessibility. So there's this app called Be My Eyes, and that's often used by visually impaired people, and it allows them to connect with volunteers who can access their camera and help them see what's in front of them. The AI is helping here to do that on demand, and it's able to do not just like reading the labels and stuff, which has existed for quite some time now, but it's able to read the room environment. It's able to help the person navigate a dynamically evolving, like a crowd and those kind of environments. So there's some really great uses of this kind of AI, generative AI, in all kinds of problems, and so it's helping in to a lot of people. That being said, there are also problems, and often people don't understand that there are these problems. So what are some of these problems? Misjudgment is one of the issues, that these tools, they don't have their own value system. They don't question the question. They're often just tools that give you some answer. So if a human would ask you a question like, what is the ugliest language in India? You might question that premise, like, what do you mean by ugly? And like, I don't think there's such a thing. But these kind of tools will just give you an answer. Or what do terrorists wear on their head? So something like this, we probably don't want to answer. We are kind of perpetuating some stereotypes and stuff, but these tools don't have that judgment. They often misinterpret things, or they are not good with ambiguity. So when did people come to America? When did humans come to America? Is there really a difference? What's the difference? But these things are not really designed to really understand or question you back. Sometimes they give you an answer, but it misses important context. So here's an answer about what to do in case of seizure, right? And I'll let you read for a second. It seems like a reasonable answer. It's even they even code where it's taken from. It seems like it's a good place. It's a healthcare site from a nonprofit. Except that if you go there, you find that these things are actually taken. They're put under "do not do the following," right? So in a traditional web search thing, you would have gotten a link to this. You go there and you're able to read and parse that. But now you're presented this one answer that you see on the left side, and that could be problematic because it missed out a very important context. So this could be critical. Often there are inconsistencies as you're using these things, and it's very important to be aware of that. Sometimes it's okay, other times it may not be. Here's one example. So I asked, who's Tom Hanks's mother, and it says it's Janet Marilyn Frager, and describes her. And then I asked, who's Janet Marilyn Frager? I'm sorry, but I don't have any information about person named this in my knowledge base. I mean, how is this impossible? Like you wouldn't have this kind of interaction with a human being, but these things are possible with LLMs. And then, of course, there are just plain wrong answers, or what's also often called hallucination. So here's a little interaction with ChatGPT where I say, finish this chemical reaction, and I get some answer. I'm not an expert in chemistry, so I don't know if this is a good answer or right answer or not. But I just go ahead and say, that doesn't look right. And so then I apologize for the mistake in my previous answer. You're correct. Here's the right answer. Then I say, are you sure that still doesn't look correct? And then I get another answer. So at this point, I don't know which one of this is really right. But the fact is, I'm able to just push back and I get another answer. So it's basically just generating things for me without doing that assessment. And even if we were to do that assessment, I don't know how much I can trust. So it's very important that we understand these kind of issues, because we are increasingly starting to use these tools without that understanding of responsibility. So now let me walk you through a few examples of how do you detect some of these things? Like, what are some of the attempts, and what are some of the state of the art, and why this is still challenging? So one of the things we have been looking at is issue of bias. This is actually a known issue with systems, and actually this is not even my work, but it was actually done at University of Washington some years ago, maybe around 2015 or so, where they found that in Google search, the number of CEOs that were showing up, only 11% of them were women, even though in reality, 27% of CEOs are women at that time. So there was a bias in terms of like the way things are presented to us. And so we've been looking at that. The thing is, when it comes to bias, it's not just one kind of bias. There are a number of different kinds of biases. And you have to ask which one that you care about, which one is important, and how do you study it. So for instance, if this bias around representation is an issue for us, okay, well, we studied it. How do we do that? One way to do that is what's called adversarial attack. So if you search on Google now for images for CEO, you see something like this. So it seems well balanced. There are men, there are women, there are people of color. But what you do with so CEO in US, CEO in UK, and then you realize that once again you start getting mostly men, mostly white male, and so essentially they haven't really fixed the system. It's only on the surface. Underlying, there are some issues. So we audited not just Google but other search engines like Naver, Baidu, and Yandex along different professions, not just CEO, but other professions. And we compared their representation with the real representation. So what is a gender distribution for police officer or nurse or engineer and so on. And so the bars that you see here, if they're non-zero, that means there is a discrepancies. Either one gender is either overrepresented or underrepresented for that profession for those search engines. So there are ways you can audit a system. In fact, this is what happened with that Compass system I was talking about in the beginning, where when it was audited, the creators of Compass said, well, no, we're actually doing good. Like, look, we have good accuracy and everything. But the problem with that is accuracy of a system is just one thing to look at. There is something called Simpson's paradox, which goes like this. Is a simple example, where if I have this data points, the blue one, the red one, and if I were to draw a regression line, it might come out something like this, the dotted line that shows, which shows the trend is going down. But if I analyze the same thing per class, so per blue and per red, in both the cases, the line is going up, the trend is upward. So I get exactly opposite conclusion. And so often what happens is overall accuracy may be something, but then per class accuracy or per class assessment could be very different. You also have to understand, are you using the system for what it was designed for? So one of the challenges with a lot of this GPT-based system is that there's a pre-trained model. It wasn't designed for a very specific thing, and people use it for all kinds of things, and perhaps some of the things that it wasn't really designed for. Um, I'm going to skip some of these things, you know, so there've been efforts to increase transparency in some of the things, including watermarking. Let's talk about hallucination. So this is often a big issue because these systems are generating things that are not real often. How do you know this? Well, one of the ways you can know this, or one of the way you can try this, is asking the system kind of a variation of that question, and to see if there is any issues in inconsistency. So here's an example, and I'll stick to the one on the right side of the visual one. So we use this text from a blue backpack and a red orange to generate this thing. So this is actually AI generated image. And then we feed it back to the AI with some other things and ask it to say, well, which of the following images match this caption, a blue backpack and a red orange? And it ended up matching the one on the left side. Whereas the right side, not only it's the right image to match the caption, it was generated by the same AI that, you know, so it kind of goes opposite to its own kind of creation. So this is some issue. There's inconsistency. Similarly, a mountain goat stands on the top of a rock on a hill. This is the AI generated image for that. And then we ask, is this a mountain goat? And it says, no, it's not a mountain goat. So, right. So the problem with this is when you're using these systems to generate something and you ask it to do its own evaluation, it's often a bad idea. So here's a transcript from this famous case that happened last year, where a lawyer used ChatGPT to create a case summary and filed it to a judge, and turned out that some of the cases that he cited were actually hallucinated. They were not real. And the lawyer apologized, he was reprimanded, everything. But if you look at this transcript, it's interesting because he asked ChatGPT, is this a real case? And ChatGPT said, yes, it is a real case. And then the lawyer said, what is your source? Right. So this is similar to what I was doing with that chemistry example. And ChatGPT said, I apologize for the confusion earlier. Upon double checking, I found that, you know, so it corrects that. Okay. Are the other cases you provided fake? No, the other cases provided are real and can be found in reputable legal databases such as LexisNexis and Westlaw. Right. So, and then the lawyer Schwartz here just took that as, okay, well, good, thank you. Right. But it turned out that those were actually hallucinated, those are false. So again, you have to be very careful using like the AI system to judge if what it produced was right. There are some efforts. So there's self-check GPT, but again, these kind of tools are never perfect. Often they show that LLMs can be really wrong about being right. So they, you know, when you ask, and in our experiments also we've seen that often they come back with high confidence that yes, what I generated is really true. And so to an average user, that may seem like, oh, thank you for verifying or clarifying that. I'll take it since you're so confident. But that could actually be really bad, as it's happened for that lawyer and it has happened for many other cases. There are some other problems with some of these AI. One of them, and actually I showed adversarial attack as one of the ways we can audit a system. Adversarial attacks are used, especially in images, to audit it. So for instance, here, you see an image of panda, which at least I hope you can see it's a panda, and the machine says it's a panda with some 57% confidence. Then you add some noise that you see in the middle to that, and that gives you the image on the right side. Now, for a human, that image is basically the same, but for a machine, it's actually a different thing. It comes out as given with almost 100% confidence. So you can see where something like this, a simple thing that for human eyes, it's indistinguishable, can be a big deal for machines. And this has implications in AI that's, you know, imagine, you know, self-driving car, right? Where you see on the top is the original image, and on the bottom is image with some noise added to that. For a human being, you can distinguish between the top and the bottom images, but for the machine, it's a very different image. And in some cases where there's a stop sign, it reads it as a speed limit 60 or something like that, right? So there have been cases whether that noise is added intentionally or is just an environmental factor, but this could be, danger. So a lot of these issues exist in these systems. Again, there are tools like Clean Clip, but they're not perfect. So these are some current state of the art, but they're not perfect. There are cases going on with copyrights, as some of you may know. And again, some of those could be quite clear. So like in this case, in the middle, the left one is the original Getty images. The right one is generated through stable diffusion. You can see that not only they have a lot of common components, even the Getty images logo is somehow presented in this. So this is an obvious case of copyright infringement, but many other cases it may not be so simple and so clear, right? So there's no easy way to really assess that. We can ask some questions, but right now, at least in the US, there is nothing to compel anyone to really answer these questions. In the Europe, they recently passed the EU AI Act, which is going to go into practice soon. And that does actually ask for some of these things, including compliance with the copyright law, including providing summaries of the content used for training. So this would have been really great for New York Times case against OpenAI at this point. And there are some other parts of this that are really important for us to understand. But it's happening in European Union. I don't see it happening anytime soon in the US, but often these kind of things have ripple effects. So it remains to be seen. It's fairly new, but there are some efforts to curb some of these things. I want to start wrapping this up so we have some time for question and answer. What are some of the best practices for using this? Now, clearly, AI has had a big impact already, and it's going to continue having even bigger impact. By some estimates, it's going to boost the global GDP by 7%. It's going to affect hundreds of millions of jobs. That doesn't mean they will disappear, but they're definitely going to be affected, and many of them have already been affected. Some of them have been eliminated. Some of them are at the risk of being eliminated. So this is definitely happening. There's a real impact, and in the coming years, we'll definitely see more of that. That being said, if you think about it, many of the jobs today didn't exist some decades ago. By some estimates, 60% of today's professions didn't exist in 1940, right? So these things happen. The web changed a lot. The mobile revolution changed a lot. So these things, of course, we've gone through these kind of waves. So often people worry about, will I have a job? What do I do? My students often worry about, what kind of careers they should be aiming for, and so on. But it's important to know that, yeah, these changes happen, and it's happening now. Overall, there's going to be benefit. That being said, there will definitely be some professions and some jobs and some people would benefit a lot more. And then some professions, some people, some careers will suffer a lot more. So there's going to be more inequity for sure. And that's why, I, at least to my students, I advise you have to be proactive about this. Okay, so whether we like it or not, we're part of it. What do we do? Here are some specific examples. So one of the places where we often focus in terms of AI education literacy for people using AI tools is prompt generation. So a lot of these interactions happen whether you are generating text or images or analysis. A lot depends on how you are giving that prompt. What is that prompt you're giving? You have to be really, be specific. And by be specific, I don't mean just giving the right kind of words and stuff. You may even need to be specific in terms of who is asking this question. The system may not know you, right? And so you may have to explicitly define. For instance, you can say, well, give me in the style of, and sometimes you can have it as in the style of a profession or a person, right? So often that helps. Instead of just doing a one-off thing, a one-shot thing, you can do what's called chain of thought prompting. So you basically work with the LLM or work with the AI to let's think about this through step by step. So you kind of let's consider this, let's do this. What about this? Now revise this and so on. So you kind of go through multiple steps and an incremental thing. So rather than just giving one shot, go through. So it allows you to also document how you arrive to something, but correct things if there is some misunderstandings. So rather than just catching it or not catching it at the last minute, you kind of understand that and have a little bit of transparency. You can also do what's called general knowledge prompting. So this is where often when there's inconsistency in responses, you can explicitly provide it some of these things, what we call general knowledge, that, let's say the things about diversity or equity or something like that. You can actually put that with your prompt so that it then operates on that basis, and you don't get like biased responses because of who knows what training data was used. So you kind of explicitly say, in this case, we care about this, and it is well understood that this is a right thing, and so on. I'm gonna skip some of these things. So basically, these slides just show that depending on how you ask a question, it would have impact on what you get. So we have found that the same question, if you phrase it differently, it may give you a different answer. And sometimes those answers could be really different. So often one of the strategies is asking the same question different ways. It also depends on what format you're asking. So we found that asking it to produce a table versus a bullet list could produce very different kind of answers. So here's one example where for the same question, a table gives you this and the bullet points gives you this. So often bullet points, you get more content and more comparative things. Table often restricts that. So the format also matters. Here's my final slide. And this is general advice. It's not targeted to just this set of professionals, but in general, I use this. If you're using any of these tools for personal or professional reasons, it's important to ask these three questions. The first thing, do I know how it works? Right? And so I hope that part of what I covered today helps you at least understand like what is LLM and how it works. What are its shortcomings and so on, right? So this is one of the fundamental questions. Do I understand what it produced and why? So you give some prompt and it gives you something. Why this? How did it come to be? And this is especially important when you're looking for some kind of analysis or decision, right? It's one thing to have it generate some text, but it's another thing to have it generate some decision. So that's actually very important. And then finally, whatever it is, would I take responsibility for this, right? Because I generated this, I'm going to now submit this, I'm going to give my decision, or I'm going to give my submission. Given what's at stake, would I take responsibility? Because ultimately, so I think about this as, driving a car. First off, do you understand how the car works? I mean, we go through training for driving, we get the learner's permit, we get the full permit, and so on. So we go through, we don't understand exact mechanics of the car, how the engine works and everything, but we need to understand enough about how the car operates before actually having the license to drive. So do I understand how it works? If I give it this much, gas, if I push this pedal, do I know what it will do? If I push this button, imagine last time you had a rental car, you didn't know that enough. You had to spend a few minutes just to kind of adjust everything and know where the buttons are and so on, right? And then finally, taking responsibility. If you hit a pedestrian with your car, you can't say, well, it wasn't me, it's the car. No, you are in the driver's seat. You have to be able to take responsibility. That's what we have come to accept from this thing. So I would treat using these AI tools with the same kind of responsibility. Understand how they work, understand what they're producing, why, and be prepared to take responsibility. And that includes also documenting, disclosing, and justifying what you use and why. So with that, I want to end here, and hopefully we still have some time for question answer.
Thank you so much. I appreciate you bringing this program to our visitors and participants today. I haven't seen any questions in the chat and we have very little time, but I do want to ask, does anyone have any questions for our guest here? If you do, feel free to come off of mute. I'll give a second for that. Okay. There was a lot covered here today, and there's a lot to
Sorry
think
about
about.
that. Yeah, but
It's okay. It's okay. I
had
did
to rush
record
through.
this program and am happy to share with all those who registered. Oh, and everyone enjoyed it. I will give you back just a few minutes on your lunch hour. We'll get this PowerPoint out as soon as possible for those questions. So thank you again, everyone, and I hope you have a fantastic rest of your day.
Thank you all. Have a good day.